It is actually not difficult understanding equation of progressive wave. You only need to remember one or two things. What are those things? The first thing to remember is that y is equal to a sine theta plus or minus phi. This is the most important equation. Now, y represents your vertical motion of the wave. A represent the amplitude. We call it the maximum displacement. Theta is talking about the angular displacement, and phi is talking about the phase angle for the particles. So now, from what I have here, you need to note those things down. From what I have here, if I have my theta from circular motion, theta is equal to omega t. And what is omega? You remember 2 pi ft. So don't forget these two. This theta that is here is equal to omega t, which is equal to 2 pi ft. This is another equation you need to note. Now, what is phi? Phi, which is called the phase angle, is equal to kx. K is called the wave number, x is called the horizontal displacement of the wave. So now, what is my k? K is also given as 2 pi over lambda, so multiply by the x. So this is also important. So all you need to know to understand the equation of wave is just these three equations. Now, your ability to relate them with one another is what gives you solutions to every of your problems. I'm going to be treating one or two questions with you in a short time. So let's quickly look at question 1. Question 1 says that the equation of a wave traveling along the positive x direction is given by y is equal to, so let's see, the equation is that y is equal to 0.25 times 10 raised power minus 3 sine 500t minus 0.025x. So if you look at this equation, it's looking like this. But now our A part represent this. So if you ask to look for the amplitude, that's your answer. That's your A part. Sine. Then this part here, 500t, you see which one represents t here, that's theta. You can see that theta is equal to omega t. So if I put omega t here, that means that that's what I have here. That means 500 will be my omega. You can see that we have gotten our answer. Then for this part now, that is the x part. That represents phi. So you can see that phi is equal to kx. And that means that my k represents 0.025 and x represents the distance. So you can see. So if I bring this equation into this place, that means that what I'm looking for is omega. And omega is called the angular frequency. And angular frequency is 500 rad per second. So my answer is going to be option C. Go through that. We are just comparing the equation. So let's look at another question. Let me come back to this. So let's look at this. A progressive wave equation is represented by y is equal to a sine 150. So let me write that out. And please follow this through. All you just need to know is how to write the equation and be able to compare them. So we have that y is equal to a sine 150 pi t minus pi x over 4. That is the equation. So if the phase difference of a progressive wave is, so you have the phase difference phi to be 45 degree, then the value of x, look at it now, you want to calculate the x in this place. So now, from what we have here, phi has been given to be 45 degree, and because it is in degree, you have to convert it to radian before you use it to solve your question. If you compare our equation, y is equal to a sine theta, because that's omega t, theta minus phi. Do you get that? So now let's bring phi out of this equation. This part represents phi. So that means that phi that is equal to 45 degree, that same phi is also equal to pi x over 4. Do you get that? Now, if phi is 45 degree, let's convert it to radian so that we can use it to solve our question. To convert degree to radian, you just need to use your theta over 360 times 2 pi. That is the formula to convert to radian. So you can say that what's my theta? 45 over 360 times 2 pi. So 45 here 1, 45 here 8, and 2 here 1, 2 here 4. So that means my answer is going to be pi over 4. So 45 degree in radian is pi over 4 radian. So if my phi is equal to pi over 4 and my phi is also equal to pi x over 4, now what do you think my pi will be? So my x will be pi over 4 is going to be pi x over 4. 4 will cancel 4, pi will cancel pi, so x is going to be equal to 1 centimeter. So you can see, so the distance x is 1 centimeter, and that is option C. That's how to solve question 2. So I left that previous question because I want you to get some part of these ones right first, then we'll go back to that question. So question 3, given the progressive wave equation, y is equal to this, calculate the wavelength. Can you do this for me? Let's write out the question. If you didn't get this very well, go over it again and solve it over and over. So let's look at this equation. So you are given that y is equal to 5 sine 200 by t, 2000 by t minus 0.4x. That is the equation of the wave. What are you looking for? Lambda. So you will think about those equations I listed the other time. Which one do you think relates lambda? You remember this part of t is your theta, this part is your phi. And you remember in phi the other time I told you that phi is equal to 2 pi x over lambda. So that means that I can say phi is equal to 2 pi x over lambda. That's this area now. So this area represents my phi. So I can use this to look for my lambda. So since my phi is from this equation that I'm given now is also equal to 0.4x, so I can equate the two of them. So I can equate this to this. So I can say 2 pi x over lambda is equal to 0.4x. X and x can go. So what else do I have? Is the equation complete? Yes. So I'm looking for lambda. So my lambda is going to be 2 pi over 0.4. So let's do that. So using my calculator to solve that, so I'm going to have 2 times 3.142 equals divided by 0.4. That's 15.7, so which is approximately 16 centimeter. So my answer is 16 centimeter. Where 15.7 is in the option. Did I say centimeter? The unit is not given, so but the unit of the option is in meter, so we leave it in meter. So our answer is meter. So now the next question. Can you try this on your own? You are asked to look for the equation of a traveling wave, and now you are given this. So let's write that out. So number 4, the question says that y is equal to 15 sine 2 over 5 into bracket 60t minus x. What are they trying to do? Why is this one out? Can you take it back inside? Yes, to make your maths easier, so that it will look like your normal equation of y is equal to a sine what is in the bracket theta plus or minus phi. So that's it. So let's make it easier. So from what we have here now, I can have my, since this, I want this to be simplified. So my y can be equal to 15 sine. So if I take this inside, that will be 120t over 5 minus 2x over 5. I hope that's mathematically correct. So now this will give me 60. So from there now I'm looking for wavelength. So let's look at this equation. Which one of them relates wavelength? It's like the one we just finished solving. That is this part phi, because phi is equal to 2 pi x over wavelength, and same 2 pi x is equal to, so phi here is also equal to 2x over 5. So I can now go from there to say that my 2 pi x over wavelength is equal to 2x over 5. So now x and x can go, so 2 here can go. So my lambda is going to be 5 pi. So what is 5 pi going to be? 5 pi. 5 pi. So what's 5 pi? That's 5 times 3.142, and that is 15.7. So which is approximately 16 meter. So that's option B. Can you see? You can try this on your own. All you just need to do is compare the two equations, take the ones that are important there, compare them step by step, equate them. All I just need to remember is this, and make sure that everything that I'm working towards look like this. So let's see if we still have a question. Okay, so let's go back to that question 2. Question 2 want us to have an equation to look like what is in the bracket. In this question, is like the reverse of what we have been solving. They have solved for frequency for you, and they have solved for wavelength for you. So now they want you to have an equation that will represent exactly that value. Do you get it? So let's get this right. So let's take option A and look for, we already know our frequency to be 550 hertz. Very good. So we are going to use option A to look for frequency. If we get 550 hertz and we also get wavelength of 0.01 meter, then our answer will be correct. So let's go. Option A says that y is equal to 0.15 sine 200. But let's take that 200 inside directly. So 200 pi times x, that will give me 200 pi x, right? Minus 200 pi times 5.5t. 200 times 5.5 will give me 1100, then pi t. So now that's what I have for my equation. You can see this equation now. So they gave me frequency from the question, and frequency is 550 hertz. So I want to see if this option A tallies. If it will give me 550 hertz, then wavelength is 0.01 meter. So if this equation gives me frequency of 550 hertz and wavelength of 0.01 meter, that means my question is correct. This equation is correct. So let's check. We won't have to go too far. So from here now, let's find frequency. Which of them relates frequency? That is t. You remember that theta is equal to omega t, and omega is equal to 2 pi ft. So this part with t now represents frequency. So I can say from here, my theta is also equal to 1100 pi t. So if my theta is equal to 1100 pi t, so what do you think I have to do now? Equate these two factors. So since theta is equal to, so I can say 2 pi ft is equal to 1100 pi t. So t and t will go. So my frequency, pi will go. My frequency will be equal to 1100 divided by 2. That is 550 hertz. So now I've gotten my frequency. That proves this one right. So let's get the wavelength from here too. If you look at the equation, this one can help us to get wavelength, right? So let's see if we're going to get 0.01 meter. So let's look for wavelength. So for wavelength, you remember that phi is equal to kx, which is equal to 2 pi x over wavelength. And the same phi here is equal to 200 pi x. So I'm going to equate this equation and this equation because phi is equal to both. So I can say 2 pi x over wavelength is equal to 200 pi x. So my x here can go, pi and pi can go. So my lambda is going to be 2 divided by 200. So that's going to be 2 times 10 raised power, because this is like saying that 2 over 2 times 10 raised power 2. So 2 here 1, 2 here 1. So when 10 raised power 2 comes up, it gives me 10 raised power minus 2. And that means that my lambda is equal to 0.01 meter. Amazing. So that means option A is correct. You don't even need to go too far. So option A will give you your right answer. If you follow it the other way around, T 500. So let me check. No, it won't be correct because option C won't give you the right answer. Option B won't give you the right answer. Neither will D give you the right answer. So you can see we are lucky because we solved it with option A. How about if option A did not give us? We have to solve for option B, C, and D. When you are used to this thing, you will actually be very fast. So get used to them and solve all of these questions. Pick your past questions and try more. And if you feel like you love what we do, you enjoy our class, please subscribe. Subscribe, please. Encourage us, subscribe. You can see my eyes are red. I'm actually kind of sick. I've been on medication, but I've had a determination that every Wednesday I have to put up this video. So, but I love you. That's why I'm doing that. So show me love. Try to subscribe to our channel. We'll continue to help you. We'll continue to be there for you. Those that are writing GC, we'll be bringing practicals, how to draw graphs, and everything on the channel. So if there's any question you have on equation of wave or an equation of progressive wave, don't hesitate to ask. And please share this among your friends in school, colleagues, partner, and those in universities. If there are questions you can't really solve that is giving you a tough time, please let us know. We'll try our best to solve it for you as well, so that you can be at home and be getting the best. Thank you so much. God bless you.